That the course again, and in this new video we'll be looking at how to balance ionic equation. How do we balance ionic equation? Now we'll start with one part of equation, we call it half equation. So there are rules for balancing half equation, and only two rules are highlighted in this place to make it very short. We need to have it very short so that it can be easy to follow. So the first thing is that you should balance the atom first by putting appropriate coefficients. In an ionic equation, there will be atoms and there will be ions. The first thing you balance is atoms. So balance atoms first. You can see the word atoms first by putting appropriate coefficient, the way you normally balance all other things in a molecular equation. Then you now balance the charges next. That's the next thing. You balance the charges next by putting electrons in the side that has higher charge. So I will give you an example now. If the left hand side has higher charge than the right hand side, you put the electron in the left hand side. If right hand side has higher charge, you put the electron in the right hand charge to the right hand side to bring down the number of electrons. Let's see an example here. Example that we have here is N3 minus, giving us N2. So this is an half reaction or half equation. Half because it only involves oxidation. You know that a full equation should be redox, should be both reduction and oxidation. So but this one is only half. That's why you see that it has only one element inside, or one species. So the first rule states that you should balance atoms first before you balance the charges. Now in this place there's only one atom of nitrogen, but on the product side there are two atoms of nitrogen. So what do? You make the atoms balanced by placing 2 at the front of N3 minus. So when you do that, the atoms will be balanced. Now we have 3 atoms of nitrogen. Sorry, we have 2 atoms of nitrogen. That's 2N. We also have 2 atoms of nitrogen on the product side. That makes it balanced by atoms. Next, that's step 2. Now we balance the charges, we balance the ions by putting electron in the side that is higher. Now how many charges do we have in this place? This is 2 times 3. 2N3 is like having N3 minus another N3 minus. That's how you have 2N3, right? So we actually have 6 minus. So you count it as 6 minus. That's 2 times 3, 6 minus. So this side has 6 minus, or minus 6. This side is 1 because there's nothing in front, so it's 1. So 1 times 0, there's no charge on it, so it's 0 charge. So this is 0. So on this side we have 6 minus, gotten from 2 times minus 3. Here we have 0, no charge at all on the element. So which of these two sides is higher? Definitely 0 is higher than what? Than minus 6. So the product side is higher by 6. So you bring it down to the level of minus 6. So how many electrons will you need to reduce 0 to minus 6? That will be 6 electrons. So that's how you balance the equation. So the equation now becomes 2N3 minus, giving us N2 plus 6 electron. So this is the balanced half equation of the reaction. So let's look at another equation. F3 plus and giving us F2 plus. The first thing is balance the atoms first. Fortunately, the atoms are balanced. We have only one molecule of Fe, sorry, one atom of Fe and also here we have one atom of Fe. So the Fe is balanced atomically, balanced by atom. Next, we now balance the charges. Here we have +3 because there's 1 here. I told you when nothing is there is 1. So 1 times 3. So we have +3 charge here. And here is 1 times 2. So here we have +2 charge in this place. So that makes the reactant side to be higher than product side, because here is 3 +3 is higher than +2. So what do? You put electron in the side that is lower, that is higher, to bring it to the level of the lower one. So here we have +2, here we have +3. So what do? Say 3 minus 2, that's 1. So you put 1 electron in the higher side. So you say plus E. So the real equation and the balance equation will now be E minus plus Fe3 plus gives us Fe2 plus. So this is the balanced equation of that reaction. So take note of that. I want to give you one shortcut. Now, this is a shortcut. Whenever after balancing half equation, if your electron ends up in the reactant side, that's a gain of electron, is a reduction half equation. So this is reduction because your electron ends up at the reactant side. However, if it ends up at the product side, like the one we did before where we had 2 N3 minus, where we had 2 N3 minus giving us N2 plus 6 electrons. Now you see that the electron here is on the product side. So this reaction is an oxidation half equation. Oxidation, because electron is there, that means electron is lost, and loss of electron is oxidation. So it's just a trick you may not find in textbook. So let's say another example. I minus gives us I2. First thing you do, balance atoms. 2 atoms of I is here, 1 atom of I is there. So what do? You place 2 at the front of I minus so that the I is 2 and the I is 2, right? Next, step 2, you balance the charges. How do we balance charges? This is 2 here times -1, making here to be -2. And this is 1 here at the back of I now times 0 charge. No charge on I2. So that's 1 times 0 will be 0 charge. So we have 0 charge in this place. So the same thing also, I2 now is higher than, the product side is higher than the reactant side. So you put electron in the product side to bring it down to the level of the reactant side. So how many electrons are we going to put there? You say 0 minus -2, that will be 2. So you put 2 electrons there. Just subtract the bigger from the smaller, just subtract the smaller value from the bigger one. It will give you the number of electrons you need to add to the bigger part to make it the same as the lower side. So here now our balance equation will now be 2I minus giving us I2 plus 2 electrons. So that's how you balance the half equation. Let's also consider this. Cu2 plus gives us Cu. Don't forget, first thing you do is balance atoms. So check for the atoms, 1 Cu, 1 Cu. Atoms are balanced. Next, go for the charges. There's 1 here, unknown, invisible one, but always there. Just like a 1x, just say x, you don't say 1x. So 1 times 2, that's plus 2 charge in this place. Then 1 times 0, I'm multiplying by charge now. So so 0 charge here. So now the 2 plus is higher than 0. That means our reactant side is higher than product side. So how many electrons are we going to add to the higher side, the reactant side that is higher? So you say that 2 minus 0, that gives us 2. So you add 2 electrons into the reactant side, 2 electrons. So that balances it. So we're going to be having 2E minus plus Cu2 plus, giving us Cu. So that will be the balanced equation, balanced half equation of that reaction. Now look at this very well. You are going to see that the electrons is on the reactant side. So the reaction is a reduction equation. It's a reduction equation. So try this question as exercise. Make it exercise 6. Make it exercise 6. Okay. Just leave it as 3. Exercise 3. So balance it and tell us if it is reduction equation or oxidation half equation. So give me feedback as we move on to how to balance a full redox equation, that is equation that contains both the oxidized component and the reduced component. That gives you a full redox equation. What is the rule for balancing full redox equation? The first rule is that you break the reaction into 2 half equation. That is the oxidation half and the reduction half. Then you balance the 2 half equations separately, like the method I taught you to balance the other ones. So when you are done balancing separately, you see that there will be electrons on the reduction side at the reactant. There will be electrons on the oxidation side at the product. So just make the 2 electrons equal, like you do in simultaneous equation, where you multiply by a particular value to make a variable to be equal. So you multiply by a particular integer that makes the 2 electrons equal. Then you cancel out the electron by joining the 2 equations together. That's step 4. Then you're going to have your balanced redox. So let me do an example with this one. So here we have Ag plus Cu giving us Ag plus Cu2 plus. So the first thing we're going to do, that's step 1. You break the equation into half equation. Now how do we do that? Ag plus go to Ag. This is one equation. Cu solid goes to Cu2 plus. This is another equation. So I'm going to be having Ag plus going to Ag. That's the first equation. I call it equation 1 if you like, but it's not compulsory. Then you can have Cu. You are going to have Cu. Let me use another marker to write it to make it different. So we're going to have Cu go into what? Cu2 plus. So I'll be balancing the first half equation. Let me make a correction here. There's no Ag plus in the first one. It's just ordinary Ag. No Ag plus. So we are going to be having equation 1, which will be Ag plus ordinary Ag okay, good. So you know the rule: balance atom first, then balance charges. Fortunately, the atoms are balanced, one silver. It's already balanced. So next, just balance the charges. Yes, plus 1 charge. Yes, plus 1 charge. Yes, plus 1. And here is 0 charge. No charge on Ag, but there's charge on Ag plus. So that means this side is higher than this side by 1 electron. So you put electron there, 1 electron there to balance it. So this is the balanced half equation for the first one. Come and do similar thing for the second half equation. You see that the atoms are already balanced, Cu and Cu. Remaining the charges. Here there is 0 charge, and here there is +2 charge. So the +2 is higher than 0. So you bring down the +2 by adding 2 electrons to the side that is higher. So I'm going to put 2e minus here. Good. So this is the balanced equation for the second one. So don't forget the way I balanced it. Here is Ag plus E minus plus E minus. That balances equation 1. Then for equation 2, Cu gives us Cu2 plus 2E minus. That balanced equation 2, 2E minus. So that's how you balance both equations separately. You know how to balance equation like that. Then next, to get a full redox, you make these 2 electrons to become equal. This is E and 2E. So what do you do to E to make it 2E? Just multiply all these equations by 2. So when you do that, it gives you 2Ag plus 2E minus, giving us 2Ag. So I've already multiplied the first equation now by 2, and it's giving me this particular answer. 2Ag plus 2E minus give us 2E. So now you are going to see that the electrons are now equal. So what do? You cancel them out. Then add the 2 equations together. That is, add the reactant to reactant, add the product to product. So now we are having Cu. It's already balanced out. So now we are having Cu plus 2Ag giving us Cu2 plus, so it's plus 2Ag plus, giving us Cu2 plus 2Ag. So that's the balanced equation of that reaction. So I'm going to write it more neatly now. So the balanced equation is giving us Cu solid plus 2Ag plus aqueous, giving us Cu2 plus aqueous plus 2Ag. So that will be the balanced equation of that reaction. So if you want to just check again, you can just rewind the video and you will see how I explained it. So let's see another example here. So the example that we have here is I minus plus Fe3 plus giving us I2 plus Fe2 plus. So once again, you break it into half equation so that I minus will go to I2 and then Fe3 plus will go to Fe2 plus. So I'll start with the I minus. So I minus gives us I2. Balance atom first. I'm balancing the, okay, let me write the second equation. Fe3 plus gives us Fe2 plus. So right now I want to balance the I minus to I2. So what do? I balance the atoms first, right? So I put 2 here to make the atom balanced. Then the charges, this one is -2 because it's 2 times -1, so that's -2 charge and 0 charge. So what do? You bring the 0 charge, reduce it to the -2 level by adding 2 electrons. So this first one is balanced. The second equation is Fe3 plus goes to Fe2 plus. So what do? Balance atoms. Atoms are already balanced. Then balance charges. There's 3 charge here, there's 2 charge here, right? So you bring 3 down to the level of 2 by adding 1 electron. So as you can see, the first equation is an oxidation equation because electrons are in the product side. While second equation is a reduction equation because electron is in the reactant side. So what do? You made electrons to be equal. There's 2 electrons here, there's 1 here. So make them equal so that they can cancel out, they can balance out. So how do I do that? I multiply this whole of this equation by 2 times 2. So that will make that the electron here becomes 2. So what would that give to us? That will give us 2 times Fe3 plus, that's 2Fe3 plus, right? Plus 2 times electron, 2 electrons, giving us 2 times Fe2 plus, 2Fe2 plus. So that's just the equation. Then what will happen? You now balance out the electrons. 2 electrons cancel out 2 electrons. Then you now add the reactant to reactant, product to product. Right? So you get your answer. So that will give us a 2I minus. So let me just open a new one. So I'm doing 2I minus plus Fe2 plus, giving us I2 plus 2Fe2 plus. So that will give me 2I minus plus 2 ion 3 to give us I2 plus 2 ion 2. So you can always check if your answer is correct or wrong in an exam, or you just check how many I is here, 2I. How many I is here, 2I. How many ion is here, 2Fe. How many ion is here, 2Fe. Right? So all the atoms are balanced. Then come and check charges. How do you know if charges are balanced? You check this place. All the charges on the reactant side must be the same as the charges on the product side. So let's see. So here we have minus 2 because 2 times minus 1 is minus 2. Here we have plus 6 because 2 times plus 3 is plus 6. Then come to this side, the product side. Here we have 0 because there's no charge on the I. And here we have 2 times plus 2. That's plus 4. Right? So now let's check if the two of them are the same. So check now. What's minus 2 plus 6? That gives you plus 4. What's 0 and plus 4? That gives you plus 4. So that means they are balanced both by atoms and by charges. So you can always confirm if your answer is correct or not based on this. So you do this exercise and try it. Write lesson 71 exercise 4 on it. Just follow the nomenclature of the exercise. So write it and balance the equation and give us the full redox reaction for it. God bless you.